Hello, welcome to another video. In this video, what we're going to talk about are position, velocity, and acceleration. So, physics is worried about or tries to study the behavior of objects. So, physics seeks to understand the behavior of various systems, okay? And the behavior for physics 1 cares largely about physical everyday systems and how they behave. Physical everyday systems, and more specifically, the motion of everyday or objects you see on Earth, okay, and how they move, but in particular motion, okay. So to study motion, we need to define 3 terms. Well, 3 plus some other terms, but it's really important to define 3 main terms: position, velocity, and acceleration. Right? Because if you're trying to talk about something, you need to know what comprises it, and you need to be able to discuss that. Okay? So, to start this little discussion here, let's imagine a particle moving in space and stopping along the way in several places. Okay? So you've got some particle, doesn't really matter what it is, okay? It starts at 1, the particle place 1, okay? The particle then moves to place 2, okay? It then moves to place 3, then it moves to place 4, and then it moves to place 5. So you've got some particles starting at 1, goes from 1 to 2, 2 to 3, 3 to 4, 4 to 5. Each one of these places, okay, that's the word I used, is a location in space. Location in space. This is a position, okay? So your position is location in space. So definition of position is a location in space, okay? Now, going back to this thing, this picture I did, going from 1 to 2 and 2 to 3, oops, I was using arrows, going from 1 to 2, 2 to 3, etc. required a position change, okay? That being the important word there, change. In doing so, the particle went some distance, okay? So distance can be thought of as a position change, okay? Now, if we look at this, there is an overall position change from 1 to 5 if you're looking at this whole thing. So overall, overall-y, that's not even a word. Overall, all the position changes together is overall all the position changes together, which is 1 to 5, is a displacement, okay? So displacement is the overall position change, okay? So let's do this. Let's just real quick. So summary so far. Position is location in space. Distance is change in position, okay? Displacement is overall change in position. Now, this is all very abstract right now because we haven't established a coordinate system, okay? So until we establish a coordinate system, okay, there is no positive change or negative change, okay? There's nothing like that. Because a coordinate system, the job of a coordinate system, right, like this, plus x plus y, is to give you some bearing on what you're doing, right? So these position changes under this coordinate system, well, 1 to 2, you could say I'm moving in the positive x a little bit and in the positive y, right? But that's only because I overlaid a coordinate system on top. Without a coordinate system, I didn't do any of that. So you'll see as we move in this semester, you'll see me establish sometimes uncomfortable, I guess, coordinate systems where, you know, up isn't positive. Okay, and I do that to help you solve the problem. So you'll see it as we go on. You'll see why I do things in the way that I do. It ultimately sets the problem up to be easier on your end to solve. But make no mistake, the point of what I'm saying here is a coordinate system doesn't influence. So the point is that the coordinate system does not influence motion. If I throw a ball through the air, how I talk about it doesn't change it, right? The ball's going through the air and it's, doing what it's doing. A chord system only changes how we discuss position, okay? And some of the other terms, okay? How we discuss motion, okay? So that's all a coordinate system does. It's just an overlay atop what's already going on. Okay. So there's one other thing I want to talk about with position velocity or position distance displacement. You'll often see me misuse, I guess is the proper term here. So I'll misuse position and displacement. That is okay because another definition for position is displacement, I guess, in a way. So you'll see me kind of use these at the same time. I'll use them interchangeably, and the reason for that is because a lot of problems only have one total position change, okay? In other words, you're only going from, whoops, have only one total position change. So you're only going from 1 to 2 anyway. And if you overlay a coordinate system on top and call this 0, then calling position 2 just position, minus this initial one gives you that same thing anyway. So in this case, in this one specific instance, position does equal displacement. And so you'll see in physics textbooks, they'll often use position as displacement and things like that. So just be wary of that. Also, distance isn't used often, okay? We really just mostly, we use it during this chapter, just so you know the difference. And one other thing to distinguish here, position and displacement can be negative after a chord system is overlaid, okay? Distance, however, is only positive, okay? So you've got position, distance, and displacement. Position and displacement, if there's really only one position change in the problem, are basically the same thing. And then distance we don't use often and is only positive, okay? So, here's the equations for position, okay? So equations for position. You've got distance, okay? Or here, let me, yeah. We really only have the equations for position change. So actually I'll do, here we go. I'll do displacement first. This delta, that's what this is called. So this is called delta. And this is a, you know, it's a Greek symbol. It represents change. X is the symbol for position. Okay? And this represents a vector. We will discuss vectors at length in its own lecture. But what this vector represents is that it can be positive and negative. Okay? So displacement with this equals x final, so this is your final position. Notice the subscript f. You'll notice that there's a lot of subscripts in physics 1. Okay, so since displacement is your final position minus your initial position, right? If you go back and look at this picture right here, our final position was 5, our initial position was 1. That's our overall displacement, which represents this red line. Okay? So from the example above, displacement equal to x5 minus x 1. Okay? All right. So now distance, and again, you'll see I will interchangeably use position and displacement. It's kind of inevitable, but this is a proper definition. Okay? So distance equals position change 1 plus position change 2 plus blah, blah, blah. So this equals x1 plus delta x2 plus blah, blah, blah equals all the changes in position. And this represents, this is an index, okay? It's used to count 1 to 5. And this just means x1 plus x2 plus x3, or if you want to add the delta there to represent the change. Okay, so this can only be okay. And the symbol for distance is just x, okay, or d. Or, because it can only be positive, these. So you can use all these. So the absolute value bars kind of make that a case, okay, or make that okay, because that represents only a positive value. And yeah, this is just a summing. This is what this is. They use sigma. Okay, that's what this guy is. It's just a sum over x here with the subscript I, and I changes from 1 to n, where n is the maximum number of position changes in that particular problem, right? So for us, it was 1 through 5, I think. Okay, but if we had 6 position changes, we would just add x5. It's just a shorthand way to write this, okay? So I know not many of you may be familiar with this sort of notation. I will try and explain every bit of notation I can. And so, yeah. Yeah, I'll try and explain it as best I can, because I know that a big barrier to physics and learning physics is the mathematical notation, but I will try and define everything for you so you know what it represents. One last thing, notice no arrow over this. It's not a vector because it can only be positive. Okay? All right. So now we need to talk about velocity and speed. Okay? It's related entity. We still need acceleration as well. So if you notice, when we were talking about position, there's one major term that came up. One thing that's required of something changing position, and that would be time. Okay? We didn't say anything about time. So when you change position, time elapses. Okay? Time changes, right? And so that's how when we bring in this topic of time, that's how we can discuss velocity. So velocity is how fast or slow, putting quotes there because that's a very generic way to describe it, you change position. Okay? So velocity is position change or displacement per some unit of time. Okay? This is what it looks like mathematically. We use a v for velocity, and it's a vector, okay, just like position is. And again, we'll talk about that. But we've got velocity right here equals the change in position or displacement per time. Speed is related to velocity. Speed is the change in distance. Change in distance per change in time. And distance, remember, was either d or just x. Okay, notice no arrow. All right. You could also, you'll see v, you'll see s oftentimes. Okay, there's multiple ways to represent this, but if you were to write this also, you can use, again, absolute value bars. Absolute value bars if you really want to. Okay, that's another way to represent it because it can only be positive, and so I really like, honestly, I think if I'm writing distance, I would probably, or just speed rather, I would be like v equals delta x over t, or I'd probably prefer s equals distance over time. Either one of these isn't ambiguous. So because of this, because of how we define this, velocity can be positive or negative. Speed can only be positive. Okay? And you'll notice something here that's developing. If we have a vector, it is defined in terms of another vector. If you have what's called a scalar, okay, it's defined in terms of another scalar. The other thing is, if something can be positive or negative, it's defined in terms of something that is positive and negative. If something can only be positive, it's defined in terms of something that can only be positive. Okay? The last type of notation here that you may see is that v Okay, this means average velocity, and then average speed. Okay, we only use this stuff, the averages, for derivations. So showing you where equations come from, really. We won't really use this in problems, but just know you can have an average. Okay. There's also technically instantaneous. Velocity and instantaneous speed. For example, if I'm driving on the highway and my average, right, over the whole distance is some amount, okay, but periodically I'm speeding up and slowing down. We typically don't cover this too much, so this stuff requires calculus. And so if we're doing calculus problems in like engineering physics or whatever, we'll cover stuff like this. But we'll touch on this, okay? We won't go super deep into detail, but I wanted you to know it exists. Okay, so the last thing we need to define is acceleration. Acceleration is how velocity changes with time, okay? So you've had position, right? Location and space. Then you have velocity, how position changes with time. And now you have acceleration, how velocity changes with time, right? There is another term that goes beyond acceleration, where it's how acceleration changes with time, and then how that term changes with time. It can actually infinitely go on, but for this class and for most people, discussion of acceleration is the only thing that's needed. So anyway, how velocity changes with time. So accel equals change in velocity over change in time. We write acceleration with an A, with a vector over it, and then delta V over T. You must be wondering, where's the positive only version of acceleration? Well, it doesn't exist. So, for example, the positive only version of acceleration would be just probably this, where you do change in speed over change in time, how speed changes with time versus how velocity changes in time. But it's not really discussed. But it would be this, okay? Now, remember how I mentioned average velocity? There is average acceleration, it does exist, and there is average accel, right? Which is this, and instantaneous. But due to the difficulty of the problems and the complexity of the problems, this is something reserved for higher levels of physics. So for us, even in engineering, we won't really do problems. A, or whatever, oops, sorry, A average will just equal A. We, in other words, accel or acceleration will remain constant. Okay? We won't really do problems where acceleration is allowed to change because a changing acceleration would require a changing force, as you'll see, which is rather complex. Okay, so we will only do this because forces will remain constant. Okay, so that's pretty much it for this lecture. Let's just do a summary. So we talked about position, velocity and acceleration. Okay, so positive or negative on this part, and then positive only. And we had position and displacement first. Okay, and so this was x with the vector sign, because it can be negative, positive or negative when you overlay a coordinate system on it. Distance is x, okay. Velocity. And again, there was other ways to represent this. This is probably the least ambiguous way to do it. Velocity and speed. So we have v, okay. Delta x over t, okay. And then we had our acceleration, which was the change and it was called acceleration for both. Apologies for that. I do think that terminology is a large reason why people struggle with physics, not just the math notation, right? But the fact that things are called the same thing, even though they're different. And, you know, like I was talking about how displacement and position are interchangeable and things like that. It really just, it can make it difficult. But hopefully this largely helps dispel any of that, and you're able to properly use the terms position, velocity, acceleration. All right, well, thanks for watching. I'll see you in the next one.